Hey everybody, thanks for stopping by for another Screwy Tuesday. I think you'll enjoy this episode. I'm going to talk about some items here within my shop. No machining, but I'll show you some items that I machined. I've got a new tool to share with you, and then we're going to go visit my good friend Carl. I think you'll really enjoy seeing his horizontal mill and a modification. And this video is kind of about modifications. What happened over at Carl's, and then some modifications here in my shop. To start off though, I just want to say thank you. I have crested the 10,000 subscribers just within the last week or so, 2 weeks. Really appreciate everybody hanging in there. I thought I was going to reach 10 earlier, and I must have jinxed myself saying that. It's funny, I'd get 180 subscribers and lose 90 each month. Pretty weird, but anywho, thank you for everybody that follows me, and I hope you enjoy, and I'll keep trying to put out some content that you find interesting. I always like sharing information that I've learned. Talking about subscriptions, I wanted to mention two other channels that you may or may not know about. One of them is the Tool Miser. I met Andrew a couple years ago. Great guy. He recently just built a shop on his property, and he's showing some of the work that's going on there as he's trying to get his machines in there and set up his shop. He did manufacture. He's got the heck of a magnet. He did manufacture and sell the Rook. Really a nice product, and I'll put a link to his channel and to his email where you can order these. It's an indicator holder, and it's got a heck of a magnet on it. That's for certain. So you can see how it picks up that wrench. The second channel that I'd like to mention is Paul Handler, and I think I got his name right there. Paul, you might have seen him if you've watched Keith Rucker's videos. He quite the machinist, fabricator. He builds miniatures, and he's got a lot of neat information on his channel, and he's trying to get the channel to grow, and I would suggest drop it in and take a visit and see if it's something you would enjoy. Okay, so modifications. So one of the modifications that took place here is, it's a simple little modification. Let's see, let me show you two photographs. One's at the back of the Monarch and one's at the front. And as you can see on the back, there was a spider, and that's my little modification I made for this. I was making parts for a new tool that I got in the shop, and I was basically a 3-foot long copper rod, 5/8 diameter, and of course it's flopping around at the end. So made it out of Delrin real quick, and if you notice there's multiple holes in it. Well, I said real quick. My real quick version of just drilling it and putting the screws didn't turn out very well. Worked, but it didn't turn out well. So I went to fix it, and I said, well, how am I going to hold this part so that I can index it? And I didn't have an interior arbor that I could use, and it finally came up. My solution was, I've got this pallet that's got a square pallet with a 1-inch stub, 3-inch square pallet, and so basically located it on there, and then it was very simple in the vise to go ahead and index it. This unit itself just slides on the back of the spindle, and once it's tightened down on the part, it can't come off. But it's a tight fit, so I have to work to get it off. So that's one modification I did here in the shop, and had some fun doing it. The copper rod I was making tips for my new tool. And let me move the camera and we'll go over and look at that real quick. So this probably gives away what my new tool is, but I needed to reproduce this guy right here, and so ended up with a collet stop in the back, so I could just figure it out once, put the collet stop in, and basically milled off a flat, so I ended up with the proper size tip there. And did a couple of those. May come back and do a couple more just to have them. I don't think my new tool is going to get used that much, so I'm going to wear them out, but we'll go over and look at the new tool. Okay, well, here's my new tool. I ended up getting a Miller Spot Welder. It's 220 volt. It, as you can see, the tips that were in it were pretty well used up. The one was actually too short, so I had to make a spacer just to test the machine. But made new tips. I made new ones with 5/32 straight tips there, and then I also, as I showed you, made the angle ones, which would get you into a small spot on the side of a box, and then a concave tip for if you're going to put a bearing in there to weld it, and then a flat tip, so if you wanted to do nuts onto a piece of metal. Still going to make one more that'll hold studs, but the unit works really well. I've been playing with it, haven't built anything yet with it, but pretty simple unit to use. You set the timer, throw the switch, pressure, and you got your weld. Whoop. There it is. Pretty sweet unit, and real excited to have it in the shop here. It'll actually weld up to a material thickness of 2 pieces together, 3/16 total thickness. So it's quite a nice unit. Right now it's just sitting on the back here. May build a stand for it at some time. Okay, so that's the modifications and new tools around my shop here, and let's go visit Carl, and we'll hope you enjoy. Thanks again for stopping by, and we'll see you hopefully next Screwy Tuesday.
Guys, this is something you have never seen before. This is the horizontal mill that was featured in Screwy Tuesday number 23, where I showed you the assembly of the gearbox and the spindle unit of this Enshu horizontal mill, taken off a Japanese warship at the end of World War II, brought into Alameda Naval Air Station in California, confiscated by the Shore Patrol as illegal war booty, sold at an auction to a small machine shop in San Jose, and eventually sold to me. Dirtiest machine I've ever seen in my life, and it took me several weeks to clean it up. But underneath all that dirt, I found just a delightful small horizontal mill. And I wanted to extend the possibilities of this mill. And I will show you the reason for what I've done after I take all this apart and show you how it is. So the next thing we're going to do is I want to show you this drilling attachment. The idea was I need to drill holes in something out here. The maximum spindle speed of this mill is around 500 RPM, way too small for efficient drilling. And the drilling would have to be done from the table, or actually from the saddle movement. And that's, you're cranking away at a lead screw. You do not have good feel. You're moving a large mass of material. It's just not an easy drilling operation at 500 RPM. So the idea was can I put a spindle speeder here? Well, yeah, there's spindle speeders available. It'd be nice if I had one that ran at 1 to 3, so 500 RPM on the mill spindle would come out to be 1500 RPM on the drill chuck. I think they exist. I haven't found one on eBay. I expect they'd be a little expensive. I've thought about ways of doing it, but then I thought, well, maybe I could get some kind of a spindle through the mill spindle itself. And so while I was nattering on that idea, I had Chuck come over, and we looked at ways of doing this. And I was going to put some kind of rack and pinion or some kind of a lever mechanism out here to operate the travel of the drill. And Chuck says, well, why don't you just put an electric drill on it? So here it is. Here's an electric drill. It works wonderful. I love this thing. So I'm going to take this apart piece by piece, show you how it was built and what it does, and we'll have a little bit of fun with this. Hang on a bit while we start taking it apart. Okay. Next we're going to go around front.
Hang on a second, we'll get set up and then come back in.
Here is the spindle. It is basically a 3/8 Jacobs drill chuck mounted on a piece of 3/8 cold rolled steel. It's got 3 flats there to go in the drill chuck, and this is the entire spindle. It is just simply a straight piece of stock with a taper adapter to mount the drill chuck. What I did was I made a hollow drawbar. This essentially replaces the solid drawbar that holds the Cat 40, or not Cat 40, but NMTB 40 tool holders in the nose of the mill spindle with a hollow drawbar made out of a piece of drawn over mandrel tubing. I installed 3 bronze bushings, oil-like bushings, 1, 2, 3, inside the tubing, and adapted some 5/8 cap screw pieces to the ends, and I have a replica drawbar. And this piece is my thrust bearing that allows me to run everything up tight. The drill spindle runs on those bearings. There's an additional bearing in the front. We're going to go around front and take that piece out and show you how the front end works. Here is the Cat 40. I keep saying Cat. I don't have any CNC stuff. This is an NMTB 40 tool holder, 3/4 inch diameter. This is an old beat up one that is no longer accurate enough to be used for milling, so I converted it to a plain bearing on the front, and that's all it is. I just put a little piece of steel in there with a 3/4 inch steel with a oil-like bushing. So there are a total of 4 oil-like bushings. All of them turned out to be quite linear, quite concentric. The drill spindle just slides right straight through with no binding. It spins with no binding, so the spindle itself is straight. It is just works wonderful. An excellent solution to drilling holes, small holes, using a horizontal mill that has a low spindle speed. Now the next thing I'm going to do is we're going to show you the problem that this was designed to solve. Before we take the vise off the table, Chuck says, let's take a look at this. This is a small cam operated, or actually eccentric operated vise made by the Skinner company, who made chucks. And it's adjustable this way, and a simple movement of the lever like that, clamps will work. Release, clamp, just like that. Kind of a high-speed vise. It doesn't have a screw operation. I don't know how much it tends to lift. I haven't put an indicator on this yet, but so far my experience with this has been it's a very nice little vise. All right, here we go. Here is the problem. This is a knee from what I believe is a Grizzly vertical mill, one of the larger models they sell. Unfortunately, there is no proof that it is a Grizzly. A lot of the tags were removed from the mill before I got it. So we're going to set it down on the table and spin it around here to show, well, let me show you the problem. The oiling system on this mill, it was, this is factory original, it was not complete. And for example, the oil comes out of here, the port, and is distributed across the surface, but there's no oil onto the sloping surface of either the gib or the fixed. Actually, there's a hole for the fixed, but there's not one for the gib. And that is also true for oiling on the saddle itself. The sloping surfaces of the dovetails were not oiled. And so my project is to revamp the oiling system, bring it up to what I consider a better standard. My particular problem on this is I don't know what I'm doing. I don't know the fittings. I don't really know much of the design of how to do this. So I'm kind of feeling my way along, thinking about things, and I decided that the major problem here is that you can see that these two surfaces are contacting surfaces, but they have relieved the contact area in the center on both sides so that as the knee wears, it doesn't tend to rock. It doesn't develop a curved surface. It'll wear down until it begins to bear totally along here, and then after that it'll begin to develop the curved surface. Unfortunately, they took more material off of this than I would really like to see. And you can see that it is darker, that the oil has stayed in this area, has polymerized, and has formed a film. And I scraped some of it off. And so what this is the oil is being pumped into a low pressure area. There's nothing that puts the oil into here other than you move the knee up and down all the time. Well, I'll distribute oil around this thing, but if you come back a day later and you want to run the oiler again, but you don't want to move this up and down because you're going to lose your height reference, well, the oil just goes here and then just kind of squirts out there and doesn't really lube this very much. So, I don't know, maybe I'm overthinking this a bit, but I think I am going to improve this. And the idea was, let's bring oil into the high pressure areas. Let's plug this holes off. Now to do that, I'm going to have to drill a hole here and drill a hole here and tap both of them, and the same on the other side. This is not an easy piece to set up in a vertical mill. You got all this stuff. I'd have to take everything off. I'd have to disassemble. I'd have to get this out of the way. It just would be a difficult job to do on the vertical mills. Perfect job for a horizontal mill. I just simply set it on the table, move it into position, drill and tap a hole. So now you know why I have the drill attachment that came here. The drill attachment has on the back side a hex, and I can drive the hex with a wrench, so I can do my tapping either under power or I can do it by hand using a wrench. So that's the purpose of having the electric drill driven speeder fed through the spindle of this, is now I can drill and tap the holes on the knee. I'm going to come back later showing you some of the details of building the lubrication system for the smaller import mills. But I want to close today with a question about end mills in a horizontal mill. Now, my smallest tool holder is 1/2 inch diameter. In milling steel, the spindle speed would normally be around 800 RPM. The fastest spindle speed available on this machine is approximately 500. A little slow. Well, it'd be nice to be able to use occasionally 3/8 and even 1/4 inch end mills, which require higher spindle speed. And I keep thinking, this is such a nice mill and so much fun to use. It would be nice to have a speeder here. And I keep thinking, well, there's a couple of ways. You can build a gear-driven 1 to 3. Be a bit of a work. I wonder about bolting something onto here that would have a motor out in here maybe and a spindle, or mount the spindle in a taper like this, put the bearings inside here, drive it through a sheave or pulley on the nose. A number of possibilities. One thing that I think I can't do, I don't think I can drive it with a spindle this long. In other words, I cannot drive it from the rear because of the discontinuous cutting action of an end mill. It would tend to set up torsional vibration in this long, slender shaft. So I don't think this rear drive, however good it is for drilling, is going to work for milling. So I'll ask you guys. Now, I think most of you have figured out by now that I don't respond to comments. I do read all of your comments, but I just simply don't have time enough to make further comments on them. My hour only has 60 minutes. I think you guys have hours that have 120 minutes in them and have time to do things like that, but I just haven't managed it. But if any of you have some wild ideas of ways of getting a reasonable spindle speed out of this, I would take and build something here, take this starter off, put a VFD on it, and a little control unit right here, and now I have just a wonderful, light-duty, very smoothly moving mill that is capable of working on surfaces that are hard to reach on a vertical mill. Okay guys, that's it for today. As I said, I will come back when I have more information on oiling systems for the import mills.
I think you'll enjoy tonight's video.